I ask for a minutes taker, and then everybody tries very hard not to make eye contact with me. Hey, Marcus, how's it going? Hey. Okay, cool. Magnus, thank you. I'm sorry to pick on you, but like, I mean, the problem is if you do an excellent job. And if there's anyone else who can or would like to jump into the, what is it called? The Etherpad replacement? The Etherpad. Hedgehog, thank you. Would like to jump into the Hedgehog and help Magnus out, that would be great. I think with that, we have started. We have a fairly packed agenda and a couple of things over the agenda that we would like to try to get to afterward. So I will go ahead and hand this over to, I've actually never said your name in Jin. Yeah. That's close enough. I will hand it over to Jin to.
Okay, we're right on the top of the hour, so let's get started actually. Welcome to Dublin, welcome to this SCONE working group meeting. And so this is newly created working group, the first working group session. And so very thanks, everybody to come. Actually, we are very glad to, have so many contributions put together in a very short time period. So it's really added a lot of excitement to this working group discussion. So very thanks for, all the problems previous of chairs and AD to make it happen. So in addition to be the new working group, and we are also a new working group chair. My name is Qingwu, and also sitting beside me is Brian. Actually, probably many of you, know Brian than me in this field, and I hope, this can be changed in the next couple of months. So we're very happy to help drive this working group, progress. And so nowhere actually, and so this is IETF meeting, and we has already, over half away of the IETF week. Probably you already, we need to make you, more familiar with this IETF noteware. And so actually, in other words, actually, if you are new to the IETF, please, understand this noteware will be applied all what you discuss here in the meeting, and also what do you, shared or comments on the mailing list, also including this meeting echo chat windows. And so you should be, abide by this IETF policy. All contributing will be the contribution to the IETF. And also you should be aware, what does that mean to you, what the RPI rules are. And if you already, are not new to the IETF, we also encourage you to, take a look at what is written in this noteware and what your application is. And, otherwise, actually, you are welcome to contribute. So this is something we encourage you to do. And next, not really well, actually. We all, everybody make a contribution. So please bear in mind, and we actually come here to work together as the IETF community. And so we have a common goal actually to really advance the internet technology. So please treat each other with respect and courtesy. And also please focus on technical discussion, listen to everybody's opinions, views, and if you have any issue or things you feel weird, please feel free to contact working group chair, us, and also OMBAT team. Actually, we're happy to help to sort it out. And so as Brian mentioned, we this agenda we propose for today is a pretty packed agenda actually. So please every presenter keep your time slot, and we'll set the timer for each presentation. So this meeting agenda will break down into 4 parts. The first part will focus on review and understand the charter description. So this will lead by the working group chair. So we will take you walk through this charter description to better understanding what the problem we really want to solve, what is in the scope, what is out of scope, what we really want to deliver. In the second part, we'll review and compare the design elaborated from the above stage. Actually, we have 3 proposals, and so we'll use this part to narrow down the requirements for the protocol we really want to build. The third part is review related work that might inform the standard protocol. We think this is related to the charter item, especially for the second charter item. And for last one, and we'll determine how we as a working group want to converge as a standard. So this we really want to, set an order for this working group and lay out our work plan and, sort out the priority work and see how to move forward. And so this is, that's some delay. Yeah, this expand meeting agenda. So any agenda bash here.
Yeah, so I have just one comment on the splitting of the various, I would say.
For remote people, hi, Med. How's it going? Please, please. Yeah, okay.
So Mohamed Bukara from Orange. Yes, the question is really clear on the, I see that you have done a job to make a call on what is in scope or not, and then you put, for example, in RLP in the related work, what you think personally is in the scope. So what logic you've allowed, or what the rationale there to call that this is out of scope, for example?
So I think there's I think what you're doing is you're agenda bashing us now to like the establishing SCONE part, because there are actually, I don't know if you saw my email message earlier this morning.
Not yet.
Please go read the email message.
Yeah,
for the record, essentially, there's also some discussion about this going on over in the chat. We as chairs have direction from our area director to take a very, very restrictive view of what's going on in the charter, right? Like, so the discussion within the BOFs was sort of, nearing maximalist scope. In order to make progress here, we basically are saying, hey, there is, if you look at like every single word in the charter, they're very, very carefully chosen. The reason that we as chairs put this agenda together in this way is that sort of like the SCONE, train, and mask proposals that were elaborated through the BOF all are looking at this very minimalist sort of area. When I read through the NRLP draft, I saw a more maximalist view of what's going on, and I really, really want to have this discussion about what requirements are we missing. But in starting with sort of a more maximalist design, I find it's way easier to do these things, in my experience as an engineer, additively rather than subtractively. Once you put it in, it's hard to sort of like slice it off. So that's my call as the chair. My AD is back there if you would like to appeal that decision.
Yeah, but I think I disagree with the, I would say with the with this conclusion, because I do agree that with the restricted scope, that's fine.
Okay.
We need to focus that all what we are doing here is that to segregate one throughput advice from the network to the host. Yep. We agree with that. That's the current scope.
Yep.
And what I'm saying is that what we have in the NRLP is exactly that, in that restricted scope.
Okay.
So I fully agree that we need to keep it exactly to the restricted scope. And I object to the current call from, because there is no discussion on the mailing list on this. There is nothing. It's and also if I record, for example, from Zahid on the mailing list, he said, yeah, this discussion will be happening in the mailing list once the working group will be happening. And now you are telling me that no, you are making some calls behind without even informing the working group. So I'd request that the NRLP can be considered as one of the candidate solutions we have there, given that restricted scope. So restricted scope, I fully agree with that one, and that's it.
Okay, I see my area director has come up to the microphone, so I will defer to Zahid.
Okay, Jahid here. So I think, Matt, I have one question for you. I mean, if you look into the draft that you have, you have more than throughput guidance in that draft, right? No? No. Okay, that's perhaps a misread for my
Did I read a okay.
I also read it differently then,
okay.
Because I was thinking like you are actually adding a lot more information than the throughput thing. But that's like, if answer is no, that's fine. You don't need to explain that one. I'll read it again.
Can we turn this into, like, let's do this. So you have a 10-minute slot. I think, can you get through those slides in 10 minutes? Yeah. Okay, cool.
So just a minute.
Well, so okay, go ahead.
I'll just finish myself then. So I did say this discussion could be happening in the mailing working group, right? I think you get a slot. Let's work through this. So this is the first meeting of this SCONE Pro. Let's get it through. Don't look into these relative things now, right now. Let's get it through. You have 10 minutes. We discuss this one, and then if working group thinks like this is not a extra work, this is within the scope of the charter, bang.
So
Let's have the discussion.
actually, yeah, let me jump in here. Actually, so don't sit down. I think so. If I look at sort of like the way the agenda is right now, I don't think it makes sense to put the NRLP discussion between the other protocols and the flavors of SCONE discussion. Can we agenda bash it so that you do it right now?
Oh, you want to do it right now?
Like that would be a
That's
way.
up to
That
you.
would that
That's up
address
to
your
you.
concern, Med?
My only concern is that we need to treat all the proposals we have on
Yeah.
the table in a fair way.
Yeah.
And
So
then we make the call as a working group.
what we're not going to have time to do in the next like 30 minutes while we're doing this is actually take that flavors of SCONE framing slides and put NRLP in there. Is that fine with you?
Yeah.
Cool. I will take that as a request to abash the agenda to reverse the third and second slots. Can anyone not live with that?
I don't want to
Martin,
say I can't.
wait.
Martin Duke, Google. I can live with it, but if like one of the concerns you whether it's in the charter, could we do the understand the charter bit first before we start presenting stuff? rather
Okay,
than
cool.
right
So
now?
I take that as agenda bash to take the second half of the chair slides, move them before. Okay, I've really screwed this up, haven't I? Actually, what I want to do is take the "you're here" part, put it at the end. Let's completely, yeah. All right. Do you want us to run? Let's do that. Okay, that's.
Can you summarize what you're coming to?
No, I
I'm
can't.
confused.
I'm just gonna do it from like.
Okay, so I mean,
yeah.
I think the synthesis of what you said and I said is review the charter,
Yes.
then have Med go,
Yes.
then go through the other proposals.
Yes.
Okay.
In that order, and we're all happy with that. Okay. Cool. Done. Do you want to run through this? Do you want to like? We have a little bit of go, but go fast.
Yeah, a little bit, screw up, right? Probably I should, So, so for the charter, actually, the water problem we really want to solve, actually, as today, actually, main application, like a collaboration with network elements. So take, this bit rate, adaptive application as a, typical example, really the network, actually, there's two pain points, actually, we really want to tackle, the first is the network element who, with this rate limit support, actually, these don't share the bandwidth location to the application at the endpoint. So this really make application to estimate the roughly the throughput limit. So this really lead to the suboptimal user experience. The other pain point is the network element with rate limit support can only publish their own the limit by actual limited packet. So this really don't communicate with network attribute with the application. So this not a really can be leverage or make a good use by each application. So what we really need to do is propose this in-band mechanism to really carry this path link metadata. So this can consumed by the application, so they can improve the user experience. So this is the goal for this working group, and go into the charter description detail. Actually, what is in the scope? The goal is working group is develop the mechanism for two things to allow two things. The first is allow the the network element to be enabled to support rate limited for 4-tube UDP packet, and the second is allow the network element to communicate the network attribute to the endpoint, and this actually is the center of the packet of the matching the UDP 4-tube, and so you will see this network attribute will be limited to this upbound achievable bit rate, including both upstream and downstream bit rate. And so this really you can see this as a notification from the network element to the endpoint. But with we have 3 points we want to highlight. The first is application is just a bit rate adaptive application. The second is we not intend to replace the existing congestion control algorithms, related, such as ECM and L4S. And third is that element may need to, provide the update of the throughput if the throughput has a dynamic nature. And so what is not in the scope? Actually, the solution we produced by this working group, doesn't need to, dig into the payload for, the encapsulating protocol, especially you apply encryption to the encapsulating protocol. So we really focus on, protocol header. The second, we really want to, not, go into, develop some kind of congestion signaling, or we provide input, which can be consumed by congestion control application. The third is the way more, narrow down, focus on throughput, don't, want to provide information more than that throughput. If that information we think useful, actually, it is not in the current scope and will be discussed in the future. And so we have go through this go and no go. Actually, when we fulfill this goal, we really want to determine, how to expand the communication from the endpoint to the network device. Two point we consider actually. First is signal capability of receiving throughput advice. The second is we can, support confirmation of the received of throughput device. So the targeted delivery we want to, focus is, how the data can be encapsulated. So we want the first we will develop the standard protocol to communicate the upper bound for the achievable bit rate, and from the network element to the endpoint. The second is how data can be used and managed. So we'll, focus on developer the informational applicability and management specification. Yeah, that's all.
So we've got quite a queue. Actually, I want to run through the next part of the chair slides that we put together, just to sort of again, sort of answer kind of the question of why we're trying to frame and how we're trying to frame this relatively restricted. So could you go forward? Can you, yeah, so you're controlling the slides. Yeah, so let's bake some scones. Next one. So I think we have sort of two goals here. I think the first goal and the first priority is to take the 3+ hand wave. We just had a discussion about that protocol proposals, quickly converge in the properties of each we need for the PS protocol doc. There are some questions that I will be asking later. You can start thinking about those questions now. The suggestion that I would make is that we try to get today to the point where we can have 3 virtual interim meetings between now and Bangkok, with the understanding that the goal for that is to have enough of a hammered out specification with a rough enough consensus on it that we can have a useful hackathon in Bangkok. That's what I'm trying to drive to. In order to get there, I would like us to focus as a working group on the first deliverable until then, really get to focus our efforts on getting to something that we can start actually playing with together with running code by the next IETF meeting. I understand that that is aggressive and possibly naively optimistic, but I don't know. This week I feel like some naive optimism might be in order. Go to the next slide. There is our second deliverable, which is applicability and manageability. I expect the discussion on this one to take longer. I think we can start working on that one in parallel, but I really want to focus us on getting the first one to the point where we can talk about running code and we can gain some sort of pilot experience with this. The discussion in the applicability and manageability document will inform the protocol, obviously. But I'd like to get the protocol to the point where, yeah, we can actually be talking about things concretely, and then sort of, eventually we will publish these documents probably together. But I want something that we can concretely talk about, where we can then have the more abstract discussion, the applicability and manageability status. So that is the goal that I'm trying to get to with the way that all of this is structured. That having been said, if I have answered your question, please remove yourself from the queue. Otherwise, please come up. Gory.
So
I think we probably want to go
So
ahead and
Gary
get started.
Fairhurst, No, it didn't answer because I have a much more fundamental question. What's the scope of the work? Because the bit of the charter about the protocol is fine, love this. The bit that comes before it, I find very divisive. Is this about SLA enforcers, traffic shapers, etc.? Or is it about network paths that have limits? In other words, is the word limiting or limiters an active device on the path that is meant to be controlling it? Is that all we're doing? Or are we also looking at networks where the path actually has limits itself rather than being artificially created by an SLA enforcer? Because the community I work with think these are two very, very different things.
My interpretation of the charter, my area director may come up and correct me on this, is that we're talking about the first one. The entire approach here is there is a device that already exists that I think that one of the terms that came out of an earlier version of the BOF was credible threats of network violence, right? Like, so putting a too small interface on a path is not really network violence. I mean, that's a philosophical discussion I don't want to have right here.
Okay.
But like, there's a box, it's configured. We want to expose that configuration information to the endpoint.
So explicitly, things like 3GPP devices, which don't actually prime force an SLA, but actually have physical layer reasons for varying the bit rate, are out of scope. Is that right? I've just destroyed your phone, by the way. There we go. Accidental violence.
Oh, accidental violence. Can we table that question until after we've seen the protocols? That's a very good question. My what is a limiter? Like my understanding of this is it's a thing that's configured. Is a slice a limiter?
Okay, right.
Yeah.
Okay, let's get clear. There are regulatory areas where putting such devices on the path is regarded as a decision that you've made, which makes this working group working in that space. If it was just the limit of the path for whatever reason, then the throughput guidance and advice seems to fit. So I think we should be very careful with whether we're limiting and have limiters on the path or whether we have limits on the path. I don't care what the difference is. If we don't care what the difference, let's remove the words from the charter or our discussions and use the right language. Happy with that one. Just think carefully. That was the comment, and it really is important for the people I work with.
Okay. Thank you. Understood. I don't think that we can edit the charter in this working group right now, but we can make decisions about how we interpret it. Hi, Lars.
Hi, Lars Eckert, Mozilla. So along sort of similar lines, and I apologize because I should have probably paid a lot more attention when the charter was written. I had reasons, but
we understand.
I have similar fundamental questions about the words UDP4 tuple and endpoint, because the 4 tuple can change throughout the network. Mm-hmm. And also, I think when we mean endpoint, we mean the congestion controller or rate controller at an endpoint that is actually the one that's affecting bottleneck queue occupancy or effect. You know what I mean? Because there can be like, think of a mass proxy or a tunnel that aggregates. Is that the endpoint, or is it the endpoint that, or the endpoints that send into the tunnel? And it might well be different. And so I think I get sort of the intent here, but I think there's some open question, at least in my mind. And again, I apologize. The answer might well be you all discuss this at chartering time and tell me to shut up, and I'm happy to like pick it up as I go along. But I read this now and I realize there's degrees of freedom that were unexpected.
So again, I'll thank you, Lars. I hope you will be okay with us not opening the what is an endpoint philosophical discussion. But there's a clarity. Yeah. There's sort of like some clarity I think we should have on how we choose to interpret the thing. My interpretation remains that what we are exposing is configured information, right? Like information, it is known, it is configured, it is again, it's a credible threat of network violence. It will actually drop the packets either because you've hit the physical limit or a configured limit. Again, not yet.
Martin Duke, Google.
Yeah.
I'm sorry.
That part I'm actually fine with.
Yeah.
I'm
It's the
an
overspecification of
implementer
it being a UDP 4-tuple.
Well, the 4-tuple is a side effect, but I'm
Okay.
so I'm an implementer of an endpoint in the browser, right? And so
Yep.
I'm trying to figure out, do I need
Got
to
it.
implement this? And I can, in some sense, maybe yes. In other sense, if you're expecting like an upstream mask proxy to do something,
Right.
I maybe so.
I think that the answer, so that's a really good question. Thank you for bringing it down to that. I think that question comes back after we get into the protocols. Thank you.
Martin Duke, Google. Let's not bash the charter this morning.
Thank you.
I do have a clarification question about the charter. Can you go to the next slide?
I have a clarification comment about the charter.
Because there was this whole discussion a second ago about like exceeding just providing throughput advice,
Yeah.
and you have the words must not and need not here,
Yeah.
and like must not means must not, and
Right.
need not means you may. And I'm wondering if that was an intentional choice by the authors. That's just kind of like an editorial mistake, and they actually mean must not.
I interpret that as an intentional choice. If there were people who are in the room there that can clarify, like they can correct me on that.
It would be good if people could familiarize themselves with the charter before coming to the working group. And also, if you thought it was contentious, look at the various history of the discussions around this. All of this language was debated both through the ISG review and in the review before that on the GitHub and on the mailing list. These need nots and must nots in particular are intentionally chosen. I believe the need not for congestion control actually came from Gori, and the intention there is to say that congestion control algorithms can do whatever the hell they want.
Yep.
And we don't want to say what they can't do.
And I would say that from the chair, my interpretation of that third need or the second need not on the third point is that the minimum thing that we are driving to is the throughput advice signal. We got to figure out what the semantics of that signal are, and we got to figure out how we're going to like syntactically represent that in whatever protocol we choose to do.
Okay.
The protocol that gets specified here does not need to be nerfed so that it can never be used for anything else in the future. My interpretation as chair is that I am deeply uninterested in spending the working group's time on that until we have something working for that first one.
Okay. Thank you. That's clear.
Stuart.
We have a lot to talk about today, and a lot of people want to talk about it.
Yep.
So I'll try to make this really quick. Can you go back to slide 6?
We can try.
One more. That's it. So if I wanted to build a traffic policer today that was
Please don't.
that was a bit more reasonable in how it works, then the way these things work is they don't actually have a buffer because they don't want to use RAM, but they have a token bucket where they count the packets, and if you use too many, they start dropping. Now, if I wanted to build something and ship it today that would work and be useful, I would set the ECN bits to tell the sender, hey, slow down or I'll throw your packets away. So when I look at this slide and it says, there is no way to tell the sender to slow down, so let's build one. When an entire work effort is predicated on an untrue statement, it makes me worry about what's coming out of it. So let's just change this to say, there is a way to do it, but we don't like it for some reason, and say why we think that a vendor who could ship a product today should actually not ship that product, sit on their hands for 4 years, wait for the working group to do something different, because for some reason the solution we could ship today is inadequate. And maybe it is inadequate. I don't know what the reasons are that what we have available today is not adequate.
Okay, thank you. So I interpret that as a request to change the non-normative slides, but I get your point, right? Like, so this is
the introduction for everybody in the room to motivate why we're doing all this work. And the motivation to me is built on a false assumption.
Right, that you can't just EC in the thing. My interpretation of what we're doing here is you have a network where, how to put it, Stuart's not building network policers, because if he did, they would be using EC, like we have this signaling, we would be doing that. Where those exist, they're not going to get ripped out because of how sort of like the forklift cycles work in these networks. We want to stick something next to it that's going to expose its configuration, right? Because that is a much cheaper change to make in production than forklifting a bunch of machines at your edge. That's, I think, why we're doing that. I would like to read that clarification of these slides into the record. Thank you for bringing that up. Dan, and I will note the queue has been closed for some time. So Dan, and then
I should be quick. Dan Rutz, AT&T. I think the problems that we heard and the issues that were raised about the scope and the problem statement can be addressed if our deliverable includes a short list of use cases that actually clarify what is the ultimate goal, rather than making assumptions based on just the statements on the screen.
Yep.
Because I think we're trying to apply intentional policies with specific values without necessarily doing sort of a slowdown or limit the rate. It's mostly trying to do self-policing on the application side based on a known intentional policy. Thank you.
Cool. Thank you. Sanjay, I'm sorry, I closed the queue.
Oh, I was already in the queue before you closed.
There's a
Oh,
there's a lock. If you look at the thing, there's a lock
Okay.
in the queue, and then there's your name.
Okay.
You can remain in the queue for next
No, no,
time.
It's good. Thank you.
Thank you. Cool. So I'm going to recalculate our speed through this charter because we're not doing great on that, or through this charter. And from the agenda bash, I would like to invite Med to come up and do his talk. The thing, yeah. Yeah, exactly. And can you go ahead and set the timer for 10? It's down here at the bottom, right? Isn't it? Down here. Triple dots.
Okay, so so this is the presentation of the I would say the NRLP specification that we have shared with the working group. We won't dive actually into the.
Okay. No, okay, yeah, just have him do the thing.
Yeah, so in the I would say in the presentation I won't dig into the encoding of the base themselves because it's not that interesting for us. So at least at this stage we will have that in a later stage. So we will just remind first the sum of installing the context why we are doing this. So I fully agree with what Brian mentioned in the beginning. We really need to have the charter really strict. What we want is that the throughput signal to be sent from the network to the host and the host to consume that. That's it. And just for that one, so I'm just reminding here that it's not new for the network to share the network property with devices. We are doing that all the time. DMTU, we are shared with the host so that they can adjust and avoid fragmentation. We are doing that with the NR. We are doing that with the prefix 64 and so on. And the network operators, they are not that closed and not are open to, I would say, include new devices there to be sent to the host if there is a value for it. That means that there is an appealing insensitive to enable them on the network. And also if there is enabling these devices, the cost of enabling them and the benefit that you will get, that the trade-off were to be had. The other point which is really important is that this may not be that visible, is that if we enable something there, we need also to be compliant with the various regulatory aspects that are in place, especially the network neutrality. So that's, for example, we are not, I would say, reasoning about the flows themselves, but about traffic categories. Because under the same conditions, it's not because you have a TikTok application, for example, or a Facebook applications that you have to discriminate between them. You have to treat them as the same under the same traffic category. The other point, which is really important, modifying this does not distort the current trust model we have in the network. I cannot that, for example, if you just send something there randomly from sources, and then the device itself behaves somewhere, and then this may lead to some fuzzy behavior. So it does not distort the device. The trust model is really important. So with that in mind, when we started working on this proposal, we really focused on the deployability of it. That means that we may design something which is really perfect, but if it is not deployable, it is not worth to spend our effort on it. So requiring something which is really complex at the data plane to write packet or to introduce another proxy, for example, on the path, just for the simple sending a simple throughput signal from the network to the host, for me as an operator, is not an appealing option. Instead of that, because we have seen some value in sharing the signals from the network to the host themselves, and we have identified them in the network, there is a room to leverage on what we have already there for various regions, because it allows us to do the atomic configuration. For example, if I need just to modify one given policy, I can just send that configuration to the host. It works. The updatability, if the policy has changed, I can inform the devices that this is something happening, so they will know about it. And again, deployability. We need to graph this and integrate it with the current network management we have in the network. There are ways we are managing it, rate limiting policies in the network. We have interfaces there to configure that. We just need to extract that signal and send it back in a given channel. And also so I am providing there various IETF specifications that we are using in our network for rate limit. So the object should be aligned with that, because we won't be changing the way we are doing rate limiting and modifying new parameters. So that's why we ended up with something that we call the NRLP, which is really a reusable block. It's really generic. If people from the mask, for example, if they find the use case for it and they want to use it, they can use it if they want. But this is not what I'm suggesting. But at least here, we have something that can be defined independent of the channel, and it can be sent over DHCP, PVD, and so on. For example, in the mobile network, there are other dedicated interfaces. They can just reuse that same blob. And we will ensure that we will have something which is really consistent, independent of the channel that you are using to send that simple signal again. So what are the feature we are providing with this? So the first one is zero trust security. We only trust the devices that are entitled to send me the configuration. No fuzzy or no random sources of information will be accepted for us. The other one is we are really what we want is fairness to applications. Any application on the host can consume the signal, no matter I would say, that application itself, because it will be exposed by the OS. The other one is that this will be independent of the transport protocol. We won't be specifying today something for quick, and tomorrow if people that they want it for TCP or for another protocol, they say, no, you have to go another channel, another cycle, and specify it. We have something from day one, something that will be applicable to any applications. And this is really important for the next feature there, what I am calling the feature parity. If you have an application which is sent over quick, for example, and then for some reason that application fall back to TCP, it may not have the same behavior because it cannot consume the signal if it was only signal using quick. We don't have this kind of problems, and this is part of the design objective we wanted for these solutions. The other one is something which is really, I would say, important. This is what we call the cascaded environment. You have devices, you iterate, you have an application, so it's using, for example, video. The dictator device itself is using video, but the network does not have this visibility. So when you will send signals to these different devices, they may be misleading because they will think that you will have the full capacity only for them, and then this will be really limited. In our case, we have something that will tell you that if this is per subscriber or if this is per device, and we manage also the case if this will be implemented, for example, in the local network. We also support indicating the policy for each direction, so that's something which is supported from the one. And one important aspect here is what we call the immune against changing the I would say the UDP flow table. For example, if you have a rate limit which is only bound to a given flow, and then the application say I have just to rebind in order to have another flow to bypass the rate limiting. In our case, it doesn't work because what makes sense is a traffic category, and this will be a guard from the OS itself to control that rate limit will be assigned to that applications independent of the flow itself. It is extensible. One aspect there, which is what we call the clear accountability model, is that because we are not touching the data plane itself, if there are any service disruption or any service degradation, it won't be the fault of the network device that has done something which is fuzzy. No, because we are not touching that. So we know when we will troubleshoot that where are the root, we have to look into it. So the application itself and the server. In this slide, this thing that we are not doing. So we don't require to reveal the identity of the server or of the application before consuming the signal. This is really neutral. Everyone can access to the information. We don't do inspection on it to have it. The other one is related to what I have mentioned previously about the zero trust. Is we don't allow random on-pad devices to inject something, for example, in the UDP part or in Quick itself to send me the device. Only the ones that are allowed can do that. We don't require any inspection in data packets to know when I have to inject the packet. Is it the first packet, the second one, the establishment of the flow? Is it the same flow for the same application? We don't have all this nightmare here. No modification to the plane. No impact on the forwarding performances. Because we are not doing the writing and we are not introducing another yet carried GradNet into the network. The packets themselves, they will travel as they used to travel today. No tweaking of the MTU because we are not having any encapsulation. No setup delay because the signal is provided to you prior to the establishment of the session. No degradation of the performance itself. We don't suffer from the multi-layer encryption because we don't have any encapsulation. Likely, we don't have any nested congestion control. Again, because we don't have any encapsulations. We don't suffer from the overhead of the annotated re-encryption if you are touching to the quick packet in some form of the forwarding pay. The last one, the one about the IP address sharing. If you have a proxy there, and the proxy has to write the IP addresses, you import all the complications we have with the IP address sharing. And you have a full RFC only for that. The reputation, the abuse, and so on, and you go through. And I save your time, just go to that RFC and see the nightmare of having the IP address sharing issues there with this kind of stuff. So I'm just highlighting.
Med, you have 7 seconds left.
Yeah, so this one insisting on the, I would say, the prevent over touching or tweaking the data packet themselves. The other bunch of them are about the, I would say, the proxy. Just to see that, yeah, operational aspects matters. We kind of just start drafting something here before taking into account the operational considerations. All of those are already in the draft. In this slide, we are just showing how we fit within the charter. We are covering both because we think that it is really important to integrate during the specification, the protocol specification itself, the operational considerations in order to drive the specification. Otherwise, we'll end up with something which is really undeployable.
All right, thank you very much. So I will open the queue for clarification questions only, 30 seconds at a time. Dan, do you want to come up? You have a clarification question on this? Huh? Yeah. Oh, I'm sorry. Sorry. Okay, good. No. Okay, good. So next up, Marcus. Oh, right. That's an excellent reason for you not to have been arm twisted by me to take notes.
So,
okay. Thanks. We're going to go through these very, very quickly, like really short clarification questions only. We have a lot of time at the end of this for discussion.
Okay.
Haha, no.
Okay. Are we good? Yeah. Okay, this is a very short presentation for a very small proposal of one way of doing this. We don't think it's the main way of doing this, but we had a lot of discussions in the chartering here, like defining what is a network element. And basically, we talked about basically anything that's on path for UDP 4 tuple. Sometimes these network elements are mask proxies for various reasons. And if you anyway use a mask proxy for some reason other than sending throughput advice, you might use that mask proxy to send throughput advice. So I want to be very clear, what we're proposing here is not to use mask proxying as the main vehicle for doing this thing we're trying to solve in this working group. But we also want to acknowledge that it's becoming a pretty common model on the internet to use mask proxies on the path of communication. And then the big question is, if you want to combine rate signaling advice with mask proxying for various reasons, do you want to use these external protocols like the train and SCONE proposals will be showing, or could we send these messages already inside the signaling channel that we actually have inside the mask connection. So if you, let's go forward. I can be quick here. So the idea is that this is a method that works with Connect UDP, Connect IP, or any other protocol that actually use the Connect method and some upgrade token that allows you to use the capsule protocol. The idea we floating here is that mask peers exchanged HTTP headers to indicate support for throughput advice. The mask server sends throughput advice using the capsule protocol. It's a very easy way to encode information that belongs to a specific tunnel over a specific path. So we have a very, very simple wire format. We have a HTTP header that says that I'm connecting through this proxy towards this destination. I'm interested in throughput advice. And then we have a capsule format where the proxy can, when and if it has a reason to send some throughput advice to the device, it can send it using a capsule. So it refers to the specific tunnel, to the specific UDP4 tuple, for instance, that is proxying. Here we have a format that the throughput advice contains a bitrate field, which is a variant, and what we call an average window. This is something that is completely, this is a stub proposal. We can completely discuss this, and probably if we continue working on this proposal, we should align whatever we send here with whatever is decided on kind of one of the main proposals. And that's it.
Cool, thanks. Questions, clarification, only 30 seconds. The queue is actually open. No, thanks. Eric, go. Eric, your 30 seconds are running.
All right, Eric Kinnear, Apple, also Mask Chair. Various reasons is usually something that'd be nice to unpack a little bit. So when we talk about what actual use case we want this for and that kind of thing. So mechanically, we can communicate a lot of things between the proxy and the client and others, but it'd be good to actually motivate what that gets us and why and unpack the various parts.
Sure. I mean, and we can definitely expand on that. I don't want to do it in this presentation, maybe, but yeah.
Tommy Polyapple. Yeah, I think it would be good to talk about the various reasons. I think there are reasons, so that's good. So just to clarify for when we're talking about like that format in there, is this pointing to a desire that like, you know, if there's something like what Train is doing or whatever, that there is some interior format that would be like identical, like here you have it as a variant, but like it would just be like, we would try to kind of define separately from the transport mechanism of that signal, just like here is the SCONE throughput signal format, and that can get stuffed in the capsule, can get stuffed in a quick version or whatever. And and then potentially also like in other proxy or tunneling protocols, maybe other than Mask too, like
sure.
If someone wants socks, I don't know. Like,
I mean, we'll define an encoding in the main specification, and I think we should apply that here in the capsule.
Yeah. Cool. Thanks. Yes. Next. Get on the SCONE train.
Right. Hey, everyone. You probably know me. Slides are coming. Right. There's a SCONE train.
I already did.
And this is about a draft.
I can do it too. It's pretty
This is joint work with Kazuo and Christian, and actually Jana has his name in crayon on the slide. It's just I wasn't able to get his name on the draft in either the acknowledgements or the author list because of communication issues. Yeah, communication is hard. So I think we all sort of know what the problem is here. Rate limiters and polices and what have shapers or whatever you want to call them tend to just damage quick rather than really affecting the protocol in a good way. So the approach we're taking, we attach, unlike what Med was describing earlier or what was in the mask thing, we're talking about attaching signals to a flow. The actual scope of the rate limits that apply are much wider, and this is a fair criticism that we heard earlier, but we do what we can. So the idea is much the same as with ECN, as the packets flow through the network and are forwarded by network elements in various ways. That gives them an opportunity to, if some of those packets have an opportunity to mark them attached to them, then the network elements can take advantage of that opportunity and get the signal through to a receiver. Notably, we're not sending signals in the reverse direction to the flow of packets that's being affected by those signals. So you might imagine that if the return path in this communication goes somewhere else, that would have a different signal. So the way we do that is we have a special quick version. The packets in that version carry a signal. And we simply have senders periodically, whenever they would like to present an opportunity for the network to attach one of these signals, they add one of these very small packets to a datagram ahead of the other packets that they're sending on for that connection. We use a quick transport parameter to establish that the actual endpoint, the quick endpoint on the other end is willing to deal with these new packets attached to the datagrams. And that transport parameter can be used in quick v1 or v2 or any other ones that recognize the registry that we're talking about. It should be relatively straightforward. Actual details follow the invariance in RFC 8999 in the absolute minimum form necessary. So you will have a quick v1 or v2 packet that you're looking to send. You generate a packet that uses the train version and the long form of the quick invariant header. And then you just copy in the destination and source connection IDs from the real packet that you're sending. That follows the rules in quick about connection IDs and making sure that things route to the right places. And then you attach in the tiny little piece that you have remaining, 6 bits, a signal. And the details of what that signal means is something that we've put big fat TBDs on in the draft. There's a bunch of ways we can do that. We can tune it accordingly. So as a network element, you're interested in sending one of these signals. You will see some packets flying by, and some of them will have these train packets in them, and some of them won't. And if you see a datagram that has a train packet in it, you can detect that it's a train packet by looking at the first 5 bytes of it. And you can inspect whether someone earlier on the path has set the limit to something that you would approve of, or if you would like to reduce that number, you can rewrite the packet to put your own limit in. And the idea is that this should be relatively straightforward for some sort of network element to be able to implement. So 6 bits, as I said, we do need a bit of help in terms of picking these, whether we use some sort of exponential encoding, or whether we have a registry as is suggested in the draft, or whether we have a mix of those sorts of things. One piece of feedback that I received was it might be interesting to have sort of some indication, if you've got one of these token buckets, how deep that token bucket is, as well as the fill rate. Things for us to consider to fill out that section. We haven't really done anything about that just yet. That of course makes it non-linear potentially, which is a complication. What if you've got a deeper bucket but a slower rate than the guy who came before you? Things like that would complicate things, but I think we probably keep it simple. Security aspects of this is kind of critical, so we spend a lot of time thinking about the security and privacy aspects of this. And the first thing is that the signal's only available if both endpoints agree to make it possible for the network to send them the signals. And critically, for the security of the thing, the credible threats of network violence kind of correspond to your ability to rewrite one of these packets. And we want to make sure the packets that get to the endpoints are real. And so the way that we do that is if the quick packet is accepted, the real quick packet is accepted, then and only then would the train signal be accepted. That prevents, or at least helps mitigate against potential attacks where network elements are able to capture packets and replay them, or just inject packets that have train packets, inject datagrams that have train packets attached to them to sort of falsify signals. So if you're able, there's a bunch of discussion about sort of the caveats on that in the draft. The net effect of all of this is that you need a 2-party agreement, both of the endpoints. I'll do it at the end, Ian, that's fine. there's some discussion in the draft about proxies. If we change the send rate, that changes the behavior of the endpoints potentially, and that change in behavior will be observable. And if we're talking about privacy preserving proxies, if you make a change to the, if you inject one of these signals and clients react to it, and your injection is on the public side of a proxy, you might be able to observe changes in behavior that correlate with that, that signal on the private side of a proxy and correlate across the proxy, which is counter to the goals of a lot of these proxies. However, we observe that packet dropping and ECN give you exactly the same sort of properties. So that's something that we might want to think about more generally, maybe not just this document. And the other thing Christian pointed out to us is that if only a few people do this, they're really going to stick out. And that's probably not good for their privacy. So we need to sort of think about who's going to be implementing and deploying this before we choose to enable it. And that's the question. All right, Ian, you have clarification.
Ian Sweat, Google. I think this is interesting. I want to go back to there's this idea that we have to know the type of content to some extent, to some big extent. Well, now I'm not saying for you, but like when we talked about things before, like ISPs and other entities sort of are attempting to do policy based on whether it's video or not, or things like that, but not necessarily based on whether it's Netflix or Google or
I think you've used your 30 seconds. This is going to be a difficult one. Can we?
Yeah, I think this. I was going to ask basically like, you know, do we want to consider having like 4 code points for like, you know, broad classifications of data because other, okay.
Okay, that's not what this is about. This is just about the throughput advice. Okay, that's it.
I think that's I will actually take that question and table it, and let's bring it back in Bangkok. Honestly.
Also, that would allow me to get rid of deploy encrypted SNI.
Yeah, please do.
Ooh.
Anything else? Done.
Nope.
Thank you very much.
Cool. Thanks. Matt. Oh, here. I was looking for you I was like, where'd he go? I'll do the timer.
Okay, hello everyone. I'm going to talk about something that we creatively called the SCONE Quick Protocol. So what is it? Quite a while back, you might have heard something that had the clickbait title SAD CDN. That's kind of this is a descendant of that original proposal that was very much a straw man proposal. And we presented a while back at Dispatch, and that's kind of what kicked off this whole line of inquiry. So this is a thing that falls out of that. It's a lot simpler. It has a lot less generalizations in terms of the directionality of the communication and the things like that. And also it has some fundamentally different properties, like the original SAD CDN did things like coalescing the packets that are between an endpoint and a network element, and it doesn't do that anymore. And the packets look like quick initials, and they use quick initial style encryption. So why quick initials is probably a good question to answer. And so the main reason is that that I think maybe a lot of people don't quite realize is that so existing rate limiters, which I know we had a lot of fun discussion about what is a rate limiter. But anyway, so there are things that exist in the internet today that are very widespread that seek to identify video traffic. And one of the ways that they do this, as Ian hinted to, is they look at the SNI. So they're like, hey, I know that this SNI is associated with video traffic, and I want to specifically target that. And when we all started using Quick for things, they were like, oh crap, now I have to actually still read that SNI. And so what do? They have to decrypt it because quick initials are encrypted with publicly known cryptography. But the upside of this is that there are already lots of network elements out there that do this kind of thing that are able to understand and decrypt quick initials. So if you use things that are similar to that, it stands to reason that you will be able to change that kind of stuff to support something like this. There's also some other nice properties like it naturally handles lack of support because we are using a different Quick version, and so Quick already supports the ability to, like, once these packets reach an endpoint, then you can those endpoints can just ignore them. So this is a screenshot of the ASCII art from the draft. The basic idea here is pretty simple. These SCONE packets are the ones that are look like quick initials. The client sends them. They are read by network elements if the network element understands it, and the SCONE packet chooses to be forwarded. It can forward it all the way down the line, and then this signals to the network and everybody involved that, hey, this flow is willing to participate in the SCONE quick protocol, and then any network element on the path is free to send those SCONE packets that have the throughput advice back to the client. And so what is a SCONE packet? Well, it looks like a quick initial. It basically looks like a quick initial up until the end where it's got the throughput advice, and then this sort of like, very much like what Marcus was saying with the mask protocol, what's at the bottom is not super fleshed out. It's just saying like, hey, this stuff at the bottom here, whatever the working group decides that throughput advice means, that's what will go there. And so that's what it looks like. And yeah, that's it.
Clarifying questions on this proposal?
Correction, perhaps?
Yeah.
Quick initial packets
Martin.
in any version. Oh, yeah, Martin Thompson. Quick initial packets in any version is not a statement that makes sense. Quick initials are defined by, like, quick packets and their format are defined on a per version basis.
What did I say that didn't make sense?
Back on the first slide, we talk about quick initial packets. So yeah, they're not initials. This is just a new.
They're initial-like. They're styled after Quick version 1 initials.
Yes.
So if you are familiar with Quick version 1 initials, these have very similar properties in a very similar format. That is what I meant.
So like a clarification statement then might be, this is a packet that is designed to be intercepted like a Quick version 1 initial because there's already intercept.
Yes, because the things are already doing that all over the internet all the time right now.
Yay, greasing worked.
Yeah.
François Michel, Apple. Just a question. Can another device on a Wi-Fi, for instance, act as a network element and forge packets?
We don't have to get into this very quickly, but that initial discussion, we're like, oh, what can do this? I agree. I think Martin and I both said this in the chat that like anybody that can do this can do this. We can't say that they can't. So it's impossible to enforce it, whether it's currently a device that's configured to do this. So obviously, yes, that's a property of this. Anybody on the path with that ability could do this kind of thing.
Yeah, so including other devices in the network, like a smartphone or an attacker, or
yes, as long as they can do the things described here, anybody could do it.
Ian Sweat, Google. I just wanted to add from recent deployment experience, there's a good chunk of the internet that does not handle multi-packet initials. Okay. If you happen to be the vendor who owns those mailboxes, you should contact me. I would like to talk to you. We can help. So maybe it's a fixable problem, but like right now, it's more traffic than you'd want to lose. Let's put it that way.
Yes.
Just as a warning for initials.
Cool.
Baby dragons.
Thank you very much. Next up, Spencer, who I understand is remote. Hi, Spencer. How's it going? It's fairly early in the morning for you, isn't it?
Yes, fabulous. Welcome from greetings from Garland, Texas. So I am Spencer Dawkins, and I was one of the 3 BOF proponents for SCONE before it was chartered. Next slide, please.
How can we actually move? Slide control transfer is locked for some reason. Yeah, go ahead and do the next slide, and then we'll try and figure out how to give them the thing.
Yeah. I'm starting with the 3 on-path SCONE proposals as of the IETF 121 cutoff. My apologies for anyone that missed that scan. And some other drafts are elsewhere on the agenda, including the including the draft that was just presented at the beginning of the
NRLP.
session. Yes, yes. And I wanted to say explicitly, these proposals are not competing. In some way, they are complementary. And the purpose of this presentation is to focus on what the working group needs as we're trying to understand the requirements at a lower level than what's in the charter. I should also mention I was asked to provide the comparison of those three protocols proposals because I am not a draft author on any of them. Next slide, please.
You have slide control now. You can go and click at the thing at the bottom.
Oh, excellent. Perfect. Like that?
Yes.
Okay, fabulous. So my first task was to go through these three drafts, comparing them to what the SCONE charter says the SCONE working group is working on. Most of these are pretty obvious because the charter description is high level. When I said client initiated, the charter doesn't take a position about whether this is necessary or is a good thing, and that was left for the working group to figure out explicitly in the charter. As I said, those proposals are not competing for adoption, at least not yet. And what I'm shooting for in this presentation is that the working group has enough information to think about what attributes matter as part of the requirements work, so we can use the best parts of these proposals along with any others that pop up as SCONE progresses. I should also say that at least one author from each draft has reviewed this presentation, and that it's obvious to me that all of the authors could update their proposals to address any attributes that working group says matter.
Martin, you want to jump in here? Or okay.
Yeah, Martin Thompson, just briefly, Spencer. I did review these slides and I did mention that I don't understand the point that you have highlighted on the slide at all. I don't know what you mean by client initiated. And so can you speak about that a little bit more?
So this is, I believe, from the charter, but that language, I think that this means something like what we were talking about with client opt-in early on in the BOF discussions. Does that help?
Yeah, so for train to work, both the client and the server need to say that they want train to work.
Yes, I think for what you're saying is that this is a yes.
I think this is a yes.
Because that's also my understanding of this column, and the presentation you just gave is also that this is a yes. So
right.
I think we can do another in-flight edit of non-normative slides and say that this is a yes and move on probably.
Right, right.
Cool.
I was just wondering whether there was anything else that was behind this that, that I wasn't understanding.
Yeah. And thank you.
Miria, is this on this point?
Mia Kudovan Erickson. So I don't know if it's a yes or no or whatever, but the difference is in this case, you not only the client can decide to do something, you always have the server to agree, right?
Yeah, and I actually talk about this a bit more later in the presentation. So,
yeah, we could.
Going to,
yeah. Yep.
Next slide.
Thank you.
So I said, great news. When you're looking at the charter text, all the proposals are close enough to at least my understanding of the charter, which is mostly talking about what network elements are telling endpoints, and most of the architectural considerations are left to the working group to figure out. So my suggestion here is that we're think about the architectural impact of these three proposals and talk about which architectural considerations matter. Kazula?
Please run to the mic.
Oh, okay.
Kazuhoku, this might be a nitpick question, but by saying that we require them to be on path, does it mean that it has to be a symmetric path, or is the requirement that it has to run on an asymmetric path? Because I didn't hear a clarification on that.
I believe, and other people may have other opinions, but I believe that this goes back to the language that we dropped out of the charter about can you do violence to packets that don't conform to the advice. So we have not really talked about asymmetric paths and doing violence to the packets or to the flows. We have not talked about that in places where I've been present.
Thank you.
So, excellent point. Thank you for asking. So I have a couple of slides of architectural differences. On this slide, I'm pointing out what the endpoint is talking to, what a network element supports, whether the advice signal is encrypted, and how device is packaged in datagrams, and whether advice appears in the same UDP datagram as the AVR media. So I'm going to let this sink in for a moment for people and then go on. I've actually got a slide that's kind of Spencer's hot take on these things as differences that might matter. But no one is running to the microphone for clarifying questions. So I'll go ahead and just put up the second one, the next slide. And this is basically sorry. Sorry. On this slide, I'm describing how throughput advice is initiated, whether the current version of the proposal supports throughput advice in both directions, how throughput advice is expressed, and how new advice values are expressed as protocol evolves. And when I talk about advice extensibility, I mean extensions to express different throughput advice, not just expressing new ranges of the current advice parameters. So I'll leave this up for a second and let this register for people.
Gory, coming up.
Hi, Gory.
Gory is running to the microphone.
I saw him blaze past on the screen.
Excellent. So it's Gory here again. No, I don't think the throughput advice field and extensibility thing actually is much of a big deal here, because I thought everybody just said they were going to send some numbers and they were going to be generally useful and we figure out what they were.
I would also expect that like anything that converges out of these, like, this will not survive contact with implementation.
Okay, so that's fine. And that's
Quick clarifying question for Brian. When you say this does not survive, do you mean the slides, the protocol, or SCONE?
First the one, then the other. No, I mean like the details of these last two rows is what I was talking about, right? Like, so these will be the first things to change when we start actually sitting down and writing code.
So that's good.
So you're talking about how the proposals might change.
Yeah.
As a result.
I am skipping ahead in your slides, Spencer. I'm sorry.
That's fine.
and moving me along is never wrong.
Okay, so I was going to go one roll up.
Go, yeah.
It was the bidirectional throughput advice is probably something we should talk about, because we can get throughput advice in each direction, and one of these methods has one way of doing it, and one of them has two separate methods, and that is a difference. I think.
That is a difference. Yeah, I think. Yeah, like thanks for calling it out. Like actually, yeah, that's one of the things I want to come out of this discussion as we pull through it is like where are sort of like the pivots that matter and where are the pivots that don't matter, because the pivots that matter we should talk about in the whole working group, and the pivots that don't matter we should have some people go write documents and make arbitrary choices that we can then get angry about, right? Like so.
Yeah, I actually have two things I really care about. Thank you for doing this, Spencer, by the way. One is I do want bidirectional throughput advice. So however that needs to happen, that'd be great. But I do need it. And then the other thing is that I don't think I looked at the slides that I couldn't find, an analysis of multipath and or connection migration. So I get that multipath isn't really a thing yet, and that's fine. But various forms of connection migration, in particular, migrating to a new ephemeral port is extraordinarily common for us. And every time we migrate to a new ephemeral port, you don't get SNI or anything else if you're a middle box. And so I kind of need a solution that like works with that.
Right. So I think what you're saying, I'm also reading that as a detailed nitpick on the UDP 4 tuple part of the charter, right? Because I think that
we're not
we're not. Yeah, but no, I mean,
yes, sure.
There is an interpretive role as part of like figuring out what we're doing here. So yeah, that's what this discussion is meant to tease out. It's like what do we need? And I think we just heard 2 good things from Ian. So cool.
Those are my needs. Thanks.
Yep. Thank you. Lucas.
Yes, and I'd just like to say I'm not actually looking at the notes in real time, but identifying what Brian called the pivot points seems like an extremely helpful thing for us to make sure that we have clear in the notes. Thank you. And that gets me to Lucas, I think.
Wait, we got Lucas?
Yep.
Hello.
Right.
Yeah, I entered the queue to ask about the bidirectional thing, but I think the other questions have clarified it. But suddenly then I looked at the next column, which was about like the field sizes of things. And just to highlight, we had a buff about HP1 this week. So if we have a 32-bit field, is that going to be large enough for maybe some of the flows other parts of the IETF are thinking about in the far future?
Yeah, and I think, and I don't know if all the draft authors would agree, but I think that the throughput advice extensibility is a really important part there, because it's not just adding new things that we're giving throughput advice about, but actual values. So I think both of those are super relevant. And thank you.
Cool.
Thank you for that observation. Excellent.
Phone train rolling.
Wait, that's one of the proposals too. I see what you did there. So possibly reasonable observations for me. These are the architectural impacts that jumped out at me. And we're, as Brian said, we are collecting pivot points that were not addressed in any of the 3 proposals that I saw when I was looking for differences. And those pivot points that I did not include are going to be super helpful. So thank you, and thank you for the people who have already identified some of those, and especially to anyone who identifies new pivot points that haven't come up yet. We have enough time for people to point out other architectural impacts in the questions on the next slide. And I'll just show that real quickly and then pop back here. What other attributes should we be looking at, and does the working group have opinions about these attributes? I kind of suspect that this slide stays up for a while during the discussion that we have that this presentation is bleeding into. But what I said were a few things. I said that SCONE and TRAIN are closer to each other than either of them are to the MAST proposal. So SCONE and TRAIN would be discovering network elements, and MAST would be discovering HTTP proxies. And SCONE and TRAIN and SCONE use of quick initial packets has implications for observability and for spoofing. We've talked about that a little bit already. And the MAST proposal says if you're already doing HTTP proxying anyway, ... And Marcus mentioned that during his presentation. I have a couple people in line already. Is that about, for you two guys, is that about this point, or is this about this slide?
I think actually at this point we're probably going to start going into the discussion anyway, and I almost want to leave this slide up as opposed to the hey y'all should talk slide.
Yeah.
Just 'cause this has some, this has the pivot point, like this has the pivot points that you'd identified, which I think is a good starting point for sort of like starting that conversation. So,
cool. Okay, so is it okay if I do the next 3 bullets? And then go to open discussion.
Yeah, let's do that real quick. Is that okay?
Okay, cool. So train is relying on endpoints that encapsulate quick packets in train packets. And train only allows network elements to update advice when an endpoint is sending a packet. That may or may not matter in practice, but it is a difference. If both endpoints don't support train, then the endpoint that doesn't is going to be dropping I want to be clear, would be dropping the quick packet that is in the train payload. SCONE only requires one endpoint in the network element to support SCONE between those two proposals. Train's extensibility for new bit rates and new advice is intentionally limited. The MAST proposal is easier to extend for new bit rates and new advice, and SCONE is somewhere in between. And SCONE explicitly provides for forwarding SCONE to other network elements. We've had discussions during the BOS and on the mailing list about having multiple network elements providing advice. I asked the question here, were we serious? But there was an excellent point that's happened in the chat so far with someone saying, so if I get advice from my mask HTTP proxy and I get advice from Train or from SCONE, which one do I believe? I think that is actually true. Anyway, so that's the bottom of my slides. For the chairs, do you want me to keep talking, or do you all want to direct the discussion?
I mean, I think we can figure that out. Like, I will direct the discussion, but like, please stick around.
Okay. Absolutely.
Abhishek.
Yeah, Abhishek from Meta. So one thing I noticed is that we do need some consensus or more clarity on the information that will be carried as throughput advice. So is it what's the process? How would the working group want to converge on that?
Can you clarify what you mean by the information that would be carried? Like, are you talking about the
So for example, in the mask proposal, there was a field for averaging window, because when you communicate throughput, you have averaging window, but then we completely missed out on things like, is it just an average rate? Is it burst rate? What is the profile of that throughput that we are trying to communicate? Because there's a lot of different kinds of rate limiters around the world which try to enforce different ways. And I think the NRLP document had a lot of discussion on the various, a lot of discussion on the richness of the information element. So my question is, how should we, maybe to the whole group, is how should we try to converge there? Should we wait for some implementations and then hit and trial, or should we do some sort of a study and bring that to the working group?
So I have a preference here that I like skip forward to in the slides that we're going to be after this discussion, which is basically I want us to get to enough of a converged proposal that we can start implementing first. I would like to try to the extent possible to separate the semantics from the syntax of these solutions, right? Like, so come up with a way to do the framing, come up with something that will make it through the network as implemented, something that is actually, that operates with minimal disruption to things that are already deployed and using quick, and then figure out what we can do inside that for throughput advice. Because I think the throughput advice discussion is going to take a little bit longer. I understand that there is like one like very major like naive assumption that I'm making there, which is sort of the entropy of these signals, right? Like, so for example, train specifically, we get 6 bits, right? So there might need to be some, like there's the, do you get like a very, very, very small signal versus a signal that's somewhat larger? Now you can do things with train. Personally, I would say, hey, we figure out a logarithmic curve that we can use to turn into a bit rate or whatever. But like I would like to try to separate those and start having that discussion once we have an implementation. I understand that we might not be able to do that. Is that a satisfactory answer to your question?
Sure. I mean, so strictly speaking, some amount of this does not need to be strictly sequential.
Yep.
Some amount of parallel work can be done just to.
Yeah. Yes.
Yeah.
Yeah. Okay. Yeah. No, that's a really good point. I yes, I prefer for these to be separate, but I prefer to us to get to something where we can start implementing early. Yeah. Let's be. Yeah. Thank you.
And well, could I just follow on with Brian and say, yes, absolutely, that it's going to be much easier for us to converge if we're talking about things that have been implemented rather than people arguing about what might be useful.
Yep. Cool. Dan.
Thank you. Thank you.
Dan Drutz, AT&T. I put myself in the queue mainly when you started adding new elements to the analysis question, Spencer, because I think currently the proposals don't address a few things, and Abhishek already touched on the format, the actual packaging could be fixed, could be variable, the value itself. The second part, and I honestly believe that this should be separated in the outcome, in the specification, as you said, basically separate the structure from the mechanism. The other part is calculation of the throughput is an interesting thing that nobody's talking about, because if I'm talking oranges and you talk apples, it's not going to be a good way to understand what exactly that. I plan to bring in a proposal to the table on that particular topic. And last but not least, the frequency and synchronization for efficiency purposes. Martin mentioned that, you can send occasionally, the train packets. Others could say, well, you send it on every quick, even if you send this occasionally, I still need to sniff through all the quick packets. I would rather have some sort of a optimized mechanism that preserves privacy, preserves, integrity, but without necessarily having to deal with all, basically looking in all the packets. So synchronization and frequency to me is important.
So what you're saying is one of the pivot points there is the frequency versus frequency. Like, so there's upsides and downsides to having.
Right, and it may be part of the manageability, but I think some of the details have to be in the architectural choice, because you need to put it in the protocol. So we need to look early on at how we're going to be, kind of making sure that this mechanism is done efficiently.
So if I recall correctly, there was a sort of last minute edit to the charter that basically said that there is a need to support update of the throughput over time. Which means that sort of things that like only do it at the front, those are now as like at the charter level, those are out of scope. But I think what I would take is like, yeah, we need to consider the trade-offs between like
as Ian
update
proposed,
frequency. Yes.
Should I be able to identify at least some high level of classes for which, the high bandwidth ones are most likely the ones that are going to be impacted by the throughput.
Yep.
Thank you.
Thank you. Hi, Ted.
Ted Hardy. I got to just say two things, one of which is about an architectural question, and one of which is about how to make progress. The first is the architectural question. I agree that SCONE and train are closer to each other than the others, and I think the primary difference is whether or not you believe that the the sender of the media needs to be part of the information or not. I strongly believe that it is better if it is, for the reasons we've discussed in the chat, because there are going to be conditions when the sender can't actually vary the media given
reasons.
Given the use case that it's actually trying to support, and that therefore signaling that this is one of the cases where variability is possible, and therefore the approach of SCONE is likely, seems to me useful. So from an architectural perspective, I think that that's something we probably want, and I'm kind of guessing we could get in SCONE with a few tweaks. And that leads me to the how do we make progress question. First, I think NRLP has lots and lots and lots of tools here. I think ECN is a little bit too slight here, and that we kind of have SCONE, train, and mask in the just right category. It seems to me mask can just track whatever is going on in the main thing and then create its capsule format to track whatever's there. So I don't think we have to put it on the main line, and I think the right thing to do is to have our SCONE and train friends get together in a design team and come back at one of these interims with a converged proposal. And I think how it converges actually goes back to Ian's question. Like, what's on the path right now that's going to stop one or the other from really deploying? And if the answer is what's on the path is going to stop multi-packet datagrams, then that's going to have a big design impact on us, and we got to know that. So I think in that design team charge, the first question is what's going to deploy, because the rest of this really is.
There's another, like, I will add something that I heard from an earlier comment, and I forget where it came from, that there's also a question about impact on redeployment of sort of like edge infrastructure as well, right?
Fair.
Like, so if your load balancer has to completely change its architecture, that's probably not going to happen, right?
Not quickly anyway.
Yes.
Okay, thank you.
Thank you. Matt?
So first off, everything Ted said is great, says one of the authors, but I agree with everything he said. So what I wanted to say was, we're talking about things that use Ted's language that could potentially hamper deployability. One thing that I think is worth highlighting is the space of throughput advice. So like we had a discussion already, like what is throughput advice? We haven't even said. We're just kind of, everyone's kind of making something up. But even beyond that, just like the amount of information that can be conveyed and how that is utilized by network operators, I think is very important. So like if we imagine that one of the use cases here that we've discussed is that these kinds of, the actual rate limits in practice are often set by business policy. So like going into the real world, you know, they are set by business decisions made by operators, and that's fine. But what that also means is that they are variable over time. So there's a desire from operators to be able to say, and I am not an operator, you know, I work for Meta, I forgot to say that, but there's a desire from them to be able to, you know, be flexible with their business practices, and as part of that, that is setting these various rates. And so that what concerns me with things like there's a lot of things I really like in Train, but one thing that I am not so happy about is the limitation of the space of potential numbers concerns me and makes me think that like we're going to run into an operator that's like, hey, you know, the CTO is like, oh no, we need to completely change our rate plans, and it's like, I'm going to do all this, and it's like the answer is, oh sorry, we can't do that. We have to update all of our software and like get an IANA point, and like it'll be, and then we have to deploy it to our entire, you know, packet core, and we can't do that for like another, you know, 18 months. And it's like that's not acceptable, right? And so that's something that I think we have to be very cognizant of, is that trying to put these lines in the sand right now is going to potentially hamper, even if it works like right now, there's these kinds of things take a long time to deploy, and what we decide now may not be the case for what is useful, say like, you know, a year or two from now. So that's what I would say.
So let me like rephrase that in terms of sort of a pivot point. You're basically saying, I mean, we've already talked about sort of the deployability, but there's sort of like a deployability versus the life cycle of the protocol, right? Like, so we don't want to have to be back here in 10 years. Cool. Thanks, Corey.
So, Corey first, enthusiast for doing something. Doing something's probably easy. Well, like this, because you figured out at the beginning. Okay, so two things about this. One, if we're going to respond dynamically to things, it kind of worries me that the protocol is going to send a particular packet that's polling for that capacity periodically. I'm not quite sure whether that's a great idea. So let's think about how we're going to do the dynamic bit afterwards, because I don't know really whether frequently polling for this is a good thing or not. I mean, let's think. The second thing is when I do service protection or protecting the capacity, I only need to do it for the top talkers. So if you're going to put this in the initial packet or something very close to the front, I don't yet know whether this flow is a big one or not. And then I have to look at every packet going past to try and figure this out. It almost seems like I want kind of like a router alert thing, which 6 months trying to deprecate at this very moment in a different working group, to tell me that this packet has something in it that I need to look at, because otherwise I have to look at everything, even for all the tiny flows, which kind of I don't really care about. So let's think about like what we do with all the traffic we don't want to be limiting, and then think about how to do dynamic stuff, and let's be smart.
Yep.
But let's also do the really quick thing fast, because low-hanging fruit's good.
Yep. Thank you, Martin.
Yeah, Martin, sitting in the Goldilocks zone, apparently, to Ted's point. I want to pick apart some of these slides because I think some of the things that have been said here are problematic. So encapsulation is not a word that we use for train. They're adjacent packets. They happen to be in the same datagram.
I've seen like a few people misunderstanding that, so I'm wondering if that's actually something that needs to be clarified in the draft.
Yeah. So in Quick, you can put multiple packets in the one datagram.
Yeah.
We're just doing that. It just happens to be that one of those packets is a different version to the other, which is not something that you typically do in Quick. And that's kind of the weird.
I think that's cute enough that it probably needs like more explanation. If we go with a mechanism like that, there's going to have to be a section about like, look at this awesome hack.
Weird. I didn't think that was a problem, but there you go.
It's because we call a packet in a packet where a datagram is also called a packet.
Yes.
The terminology here is very clear, but also very poorly used generally because we're really sloppy.
Yes.
The other thing.
It's the story of my life, Martin.
Yeah. So the other thing here, I think there's some aspects in the train design that are very deliberate and relate to the security question and this credible threats of violence point that we keep coming back to. I think if you have a design like SCONE, you end up with the potential, far greater exposure to the potential attacks that you get from just stuff, injecting packets and spoofing addresses and what have you, and causing havoc. And I don't want to have that as a characteristic of the protocol. And I think it's a very important distinction between the two proposals. Yes, they're closer to each other in a lot of the ways that we care about, but in this key security aspect that I care about quite a bit, I think this is a critical distinguishing characteristic that is worth separating the two.
I think that like minimizing havoc is not explicitly in the charter, but I think that we should assume that it is, right? Like, so this is when I'm speaking of sort of like, interpretation. And I think this would be another one of those pivot. Like we've identified another pivot point, right? I think that like, but minimizing havoc seems like an implicit requirement.
Exactly.
Yes.
I'm like, where are we again? I mean, right. So first, do no harm. Okay. So there's that. The bitrate limit, the bitrate of throughput advice limits that are in train are also somewhat deliberate. It's a little constraining, only having 6 bits. I acknowledge, and I understand Matt's trepidation about the potential for that to be a problem in the future, but we don't know what 6 bits are being allocated to just yet, and so I think it's a bit premature to start attacking.
It's another one of the reasons.
Snowman.
That's another one of the reasons that I, as chair, am saying let's try to keep those two things separate, right? To the extent that we can.
Right, and so one of the things that we need to do is have that exercise, and I think Dan mentioned, and I thank you for that. You want to have a proposal about what sort of things you want to be able to signal. that's a very useful contribution. The authors on this document, on train in particular, are just not qualified to make those statements, and so we didn't. We need your help.
So, like with
Yeah.
how we're going to get that help, I have reserved myself 10 minutes at the end of this session to sort of like talk about next steps. There's 11 minutes remaining. There are 9 people in the queue. The queue is closed because I don't think we're going through one person per time, but let's try and keep it brief. Thank you. Kazuo.
So there's Havoc that we discussed, but I think we have to care about other security aspects as well. So if you look at SCONE and train, SCONE sends new packets in response, while train modifies packet. And the difference there is that if you deploy multiple middle boxes in the middle, it can be intentional, it can be by accident. Then there's potential of having an amplification attack vector. If a packet is generated in response to one packet traversing through. So we have, maybe that's only one example, but we have to think about the security aspects before choosing a proposal.
Yes. Tianji?
Yes, Tianji, China Mobile here. Because I want to talk about the usability from the operator point of view here. Because here, when you compare this like a SCONE, the objective to expose the networking related information from operator domain to the end host. Now the thing not like before like a LFS ECN, that's on the network level. But now here like a throughput otherwise, though we have not defined parameters of what will be exposed, but it's more than, well, from my understanding, it's more than the networking level is asking. So that means for the usability and the controllability from the operator is very important. Because at the end, when no matter which protocol is selected, when it's matured, it's deployed, it's under, well, I'm not saying the mercy, but since the operator will have the things, say, okay, which one to use, all kind of things. So in that case, when talk about deployability and controllability, you'd better have some protocol that going to give the control to the operator about the things. Not like, well, in terms of this, I like the sort of like overlay things, more like the mask signaling variation things, such that for operator, we want to have some control about these things. Because you're asking more information from us. So that is the thing. Thank you.
Thank you. Tommy? Actually, I'd ask if people who are in the queue could actually come up to the queue, and like we'll have like a physical queue of 3 deep so that we can go fast.
That's a good point. All right, Tommy Polly, Apple. Just overall, I want to kind of emphasize and support Marcus's point about like the proxying mask solution coexisting with something like train. I think that's a very nice way forward. Specifically, like with the mask stuff, like gives it an easy place that we can do measurements and experimentation. And it's kind of like more almost like a testing tool right now. Like long term, yes, it's a thing that clients can trust, and maybe they're more willing to do in some cases, or if they're trying to do some privacy solution. But also, like it makes it really easy to have something that is on path right now. Like we can choose it to be on path when we're doing a hackathon thing. And I totally think that something like train or SCONE makes a lot of sense for the generic case here, and that we need to figure out how we converge that. So I just suggest we kind of like potentially even have kind of 2 tracks of work. Like one is to converge train SCONE approach and figure out that. But then in parallel, we can have some experimentation around what are the contents of those bits, how they're going to be used, and we can do some experimentation potentially in a mass capsule setting of you can hackathon that around, and then that allows the people who want to just go into that world to start iterating there and do some of this work separately.
Okay, cool. That's a really cool way to implement. I think it was Abhishek's point of maximizing parallelism. Thank you, Tommy. Sanjay.
Hi, Sanjay Mishra, Verizon. So just going back to the point where Abhishek was pointing out the fact that there needs to be some values that sort of define the upper bound and the lower bound in some ways that says what the adaptive bit rate, it's not one single thing, so that something that team can put together sort of upper bound, lower bound parameters, and so that can address different moving parts. And that actually goes back to, again, not a criticism on train, but that sort of the number of bits, I know it's not a final product yet, but that sort of limits in terms of what the rate limit might be, because the data plan varies and it varies across the operators and it changes. So you don't want to be coming back here, not in 10, but probably coming back in like 1 year if we limit ourselves to those types of constraints that we can avoid.
Thanks, Ian.
Okay, thanks. Okay. So actually wrote things down. Less CPU is good. This makes me lean towards SCONE or train by default. I mean, this is going to be deployed on video servers that are commonly very CPU sensitive. I definitely want something that's multipath friendly / connection migration friendly, because it's a problem today, and I don't know what operators do, but I'm sure they do something. I need something that's bidirectional. I mean, I don't know. I don't need to indicate the type of traffic, at least for now. I have now convinced myself that that is an interesting aspiration intellectually, and it completely doesn't matter, because we can just mint a new version later. And if I want to do video conferencing, it's not really even clear that bit rate's the number I want. I don't know. I'm not sure. Like, we'll get that when we get to MOQ, real-time stuff, and we can talk about that. All right. And injecting packets kind of makes me scared the more I think about it. And so I think that biases me towards the train direction at the moment. But and I figured the code point thing, like, we only have 6 bits now. Couldn't we just add another byte or something? Like, it seems like a solvable problem. Like, we could change the framing if we wanted more bits. Solve it later, whatever.
I think one of the things I'm hearing a lot is, like, basically there's sort of 2 work streams here, and they will have to talk to each other.
Yes.
And we should support both of those.
But I support moving forward with something soon.
Yes.
So we can actually start doing the work.
Excellent. Thank you. Spencer.
Can you put me to the end?
Yes. Oh, well, actually,
Thank
I can pop you out, and then you can put yourself back to the end. Chris.
Cool. Well, of course, the queue is locked.
I just unlocked it.
Okay.
Thank you all for, like, going through this quickly. So,
Right, okay.
like,
It's Chris Seal, Hutchison operator. I'm bothered by the idea of just a single number in terms of the bit rate that could go. And one of the things I have in mind is that I would want to give a sort of multi-advice in one go. So it'd be like, hey, if you're on 5G, you can do this. If you drop to 4G, do this. And
okay, so there's other,
I don't need mask proxies or anything to go and keep changing advice. And the other thing I sort of think about is that consumers tend to sort of flick between videos lots. So they watch first 10 seconds, move on. So I'd like some persistence in this. So you don't keep asking for every video. If you've got the answer 30 seconds ago and you've changed video, so what? It's still valid.
Yep. Thanks, Maria.
Mia Kulevin, 2 points. First of all, I think in line with maybe what some people said, I think the mass proposal is actually complementary here, and we should like start working on it right now. And then on the other 2 proposals, these are not competing against each other. We have to look at all the what you call pivot points or the main design difference and figure out like why we made a decision. And all the things we discussed are related to different decisions on either deployability or security. And we really need to look at each of these points, understand what was the motivation regarding deployability or security that has driven this decision, and also then look at like how can we like picking one or the other, what's the impact on security and deployability. And at the end, and this will be the hard part because we want both. We want a protocol that deploys, that people are able to deploy and willing to deploy, and we want a secure protocol as well. Right.
Thank you. Yeah, on the mask point, I just want to say something that I'm hearing sort of emerging from this discussion pretty strongly is that mask is complementary, that we should probably work on having mask formats that have the same data and information model as whatever we come out with, so that we can use that now. Because I mean, like we're a lot closer to having code that we can put on the wire and actually start playing with mask now, and then that remains a parallel deployment option in cases where we have sort of like things on path. So that's going to come into the discussion that we're going to have in a couple of minutes. But first, we have Daniel.
And we're talking about throughput advice given by network. Anyway, I would assume it will give the throughput device from the perspective of its overall forwarding capacity. So there will be cross full tube to flows coordination involved, but I did not see in any slides yeah. And the second point is that I would assume there will not be each network element or network node along the path will give the throughput advice. It should be the bottleneck link involved node to give the feedback. I do not see why it had not been explicitly stated in our drafts or the charter.
Actually, Daniel, could you follow up with Magnus? He is missing some of your comments here. He wasn't able to get them. Like after, check the transcript after the meeting, because we would like to get that for minutes. Thank you, Spencer.
Thank you. So I just wanted to follow up on a couple of things that people have said. We've had conversations with Lucas about quick load balancers. The important question is going to be where the load balancer is, whether it's before or after a network element that's doing whatever the SCONE protocol turns out to be. For Gory, we shouldn't need a poll if we're doing ABR, because all the ABR mechanisms that we know about are providing feedback also. So it's not like if the advice changes, you don't know what to do until you start losing packets. For Martin, I want to agree with Martin strongly that the working group needs to focus on security very early in the process. Yes, that's really important. For Ian, the reason that type of traffic doesn't matter is because the advice is only going to make sense when you can use it. The words the letters ABR don't appear in the charter anymore, but that's a recent edit out, and we've been definitely since the beginning thinking of people who were doing ABR, but we don't care what traffic you're doing something like that with. Thank you all for all this great feedback, and I look forward to watching everyone light up the mailing list starting at the end of this session.
Absolutely. Thank you, Spencer. Okay, I'm going to take back. We have about 8 minutes to figure out what our next steps are. I have heard a lot of suggestions around a design team, so I'm going to take sort of like the answer from the discussion that I have seen so far is do we need a design team as yes. Are there any like extremely strong suggestions? Ian is on the design team and so is Dan. Yeah, okay, good. I actually want to take the volunteering to the mailing list because I want names associated with it so I can make sure that we follow up on. Ooh. Two aspects we're talking here, 2 design teams. Yes, and Ian's on both of them. Yeah, no, so no, that's actually a really good point. I think there's one for sort of like the content of the signaling, the semantics, and one is for the syntax and how we actually do it. I really like that idea. We will take that to the list as to who signs up for the, no. I don't like that idea. You don't like that idea. Can you come up and talk about why?
I think the two are too closely related for that to be effective. And so if you go off in one side and you decide that you want the signal to be 1 megabyte of XML, and
no havoc is an implicit requirement.
And the other side, you pick train. That's an interesting compression technique that you've credited.
Let's so
that sort of thing.
That objection makes sense to me. I think we have 5 minutes in a relatively deep queue, and Spencer's ahead of you, Dan. And actually, Spencer, do you mean to be in the queue? Anyway, we don't.
Yeah. Yes. No. Yes. I popped out. I popped out, and then I'm popping back in for this. If you're thinking of a large number of virtual interim meetings, and by that I mean more than two, before before IETF 122, the authors got to do fairly quick presentations, like between 5 and 10 minutes. And then people listened to me on my best take of 3 of the 4 proposals that were presented. It seems like that letting the people present those proposals and and take questions on them seems like an excellent agenda for a first virtual interim meeting before we ask them to merge.
Yep.
Thank you.
Okay. Cool. Dan, 5 seconds, please.
Dan Dutz, AT&T. First of all, I think we're putting the carriage before the horse. I emphasized on the need to clarify the use cases, because I think I see in the chat we're kind of talking over each other about what it should be done, and maybe clarifying what is the actual conditions, the situations in which we want to enforce this. The second part, I agree with Martin that we don't need to define the actual format, but I think the requirements for the throughput can be defined sort of separate from the actual proposal, the architectural choices. So not necessarily specifying the actual data, but we know what we need. So if we know what we need, then we can actually look at how those match with the architectural options. Thank you.
Okay, I'll be very brief. I think Martin has a very good point about we might have very different requirements coming in there. I think it's still valuable to have 2 tracks of work, maybe scoping up requirements and understanding of what we want to get out from a throughput signal. And we have another set of requirements around security of a mechanism and so on. And I think these can be done in parallel.
I would amend that to security and deployability, but yes.
Yes, exactly. Yeah. And then, we have to coordinate tightly. Maybe we can send liaison statements.
No. Martin, are you happy with 2 work streams, and we'll figure out how we organize the work so it doesn't diverge? Cool. Gory.
Yeah, and there's a lot of people here, more than I expected. So how do we get all these people in the loop when we do the design team? Let's be careful with that. Doing requirements in the design team, super good, presents some. Doing protocols, yeah, if it's a straw man. But please don't do too much in your design team before we synchronize as a whole group and get on the same page.
I would say all protocols are straw men. Some of them deploy to production and stay there for 50 years. Maria.
Yeah, I actually don't think we should have a design team at all. We have like one very clear scope charter that this group is working on. Let's work on this in this group. Like if we get a problem what you can't solve, like a very specific one, that's when you go off. And have like this more intense discussion.
Okay, so
let me say one more thing. Usually, if you have 2 proposals there, to wait to get to 1 proposal. One is you also talk to each other and like propose 1 proposal, or each of the groups develop their own proposal until we converge.
Okay, cool. So 2 work streams, no design teams. I mean, yes, you can. No, I'd sit down.
Okay, let's say what I think. I like what Maria said. So if we actually ask for 2 design team or design team, you'll get a lot of hands.
Yep.
Everybody wants to be in design team, and then we are creating a working group inside a working group. I don't want that.
Yeah.
So please organize this one as like go through it like the 2 streams that we're talking about, and see like if there is a specific thing where basically we need to focus with design team. That would be my suggestion. And also like another thing that I would like to say, like there was some initial discussion when we started this session about some understanding like what this rate limiter or everything like that. I don't think like we have a rate limiter thing anymore in the charter, if I am
mistaken.
It's there. It is there. Okay. But anyway,
it is there is a difference in interpretation, which I would actually hope that the work stream that is working on sort of the semantics of the signaling it should fall out of that work.
Okay. So the point I wanted to make, like when people have misunderstanding and all this, I want to discuss, I would like to understand what this discussion, like whatever rate limiter, limiters, whatever thing, how that impacts the SCONE protocol.
Yeah.
Because how you how you send the signal, how they calculate bit rate, I think out of this charter discussion. So even if there's this matters for the design teams or whatever design principles, I would like to know like how that impacts rather than how you make those decisions, how it impacts on the protocol design, because that's important here. Thank you.
Okay, cool. Thanks. Going to my other questions on this slide in 70 seconds. I think we have gone ahead and established the IETF WG SCONE repo. I would encourage people who are working on converging documents in this space to make use of it. My intention is to schedule 3 virtual interim meetings, 1 per month between now and between 2 and 3, I would take that to the list, where the idea in the first one is that we really are talking about sort of like slamming sort of like the protocols together from the syntactic standpoint, like figuring out what the pivot points are, coming to a conclusion on those, hopefully with sort of like worked examples of how we can meet those. And I would follow up with the scheduling of that on the list. Like, I understand that like finding time for 3 of those between now and March is going to be really difficult. Finding time for 2 is not going to be easy. Yeah, we will announce the dates real soon. Like, I would actually, I as chair will be around the hallway for probably most of the rest of the day as well as all of Friday. I know that we don't like Friday meetings, but like we can sort of like meet in the hall and come to and like have some high bandwidth discussion that we take to the list and figure out the planning real soon now. If there are no other points, we have no other time. And I would like to thank everyone for a very productive, high energy working group meeting. And I will see you on the list and in the hallways and travel funding willing in Bangkok. Thank you very much.
I just wanted to say thank you all. Have a great day and make good choices.
So I asked Gemini to give, like, that's a SCONE chair, as like, hey, draw me a picture of a SCONE chair. And the funny thing is that I ordered a chair that looks almost exactly like this, and it'll be coming in November. But like, it's like, holy crap, I have a SCONE chair.